Okay, so let's just jump right in. We're in the middle of this revolution in how we create and understand knowledge. But there's a huge catch, right? It's this overwhelming flood of information. Today, we're going to look at the AI tools that are helping researchers do more than just tread water. We're talking about tools that let them navigate this deluge and find insights way faster than we ever thought possible. So just to give you a sense of what we're up against, get this. Over 5 million academic papers get published every single year. Think about that. That's a new paper coming out roughly every 6 seconds. Our brains, as amazing as they are, they just can't keep up. There's no way. This isn't just some small hurdle. It's a full-blown crisis of information overload. And that number? It has a very real human cost. You see, a single traditional literature review, and I mean the gold standard kind, can take over 1,000 hours of work. 1,000 hours. This creates this massive bottleneck in science. Researchers are spending way more time just looking for the information than they are actually analyzing it. Progress just grinds to a halt. So, what's the solution? How do we fix this? Well, the answer is a total shift in how machines read, or maybe I should say understand, academic work. We're leaving behind the old days of just matching keywords. We're now in an era where AI can actually get the concepts, the real ideas buried in the text. And this slide really breaks down the difference. It's huge. Think about the old way, keyword search. It's super rigid. Let's say you search for energy storage materials. Well, you could completely miss a game-changing paper just because the author called them battery electrodes. You'd never see it. But semantic search, that's different. It understands that those two phrases are talking about the same thing. It's searching for the meaning, not just the exact words. And that changes everything for getting relevant results. So the magic behind all this has a name, Retrieval-Augmented Generation, or RAG for short. And this is so important because it's our built-in protection against AI just making stuff up, right? Those hallucinations we hear about. Instead of pulling answers from thin air, a RAG system does something really smart. It first goes and retrieves information from a specific verified set of documents, say the stack of papers you gave it, and then it uses only that info to answer your question. It's a game changer because every single thing it tells you can be traced right back to the source. Okay, so we've got the tech down. Now let's see what this looks like in the real world, with the actual tools researchers are using. Honestly, the number of these platforms is just exploding right now. So to make sense of it all, we're going to break them down into a couple of key stages that pretty much follow a researcher's typical workflow. All right, stage 1, discovery. This is all about that classic problem, right? You found 1, maybe 2 really great seed papers, but now what? How do you find everything else that's connected? That's exactly what these first tools are for. And they don't just spit out a boring list. No, they create these amazing visual maps of the whole conversation, so you can literally see how all the ideas link together. And what's cool is they all have their own flavor. Litmaps, for instance, builds these beautiful graphs based on who's cited whom, so you can trace the history of an idea. Then you've got ResearchRabbit, which lets you go down these discovery rabbit holes, and it saves your whole journey. And Connected Papers is different again. It groups papers based on how similar their ideas are, which is awesome for finding those hidden gems that nobody's cited yet. Okay, so you've mapped the universe of papers. Awesome. But now comes the hard part, pulling out the key info from all of them and actually comparing it. That brings us to stage 2 and our next set of tools. These things let you look across, dozens, sometimes hundreds of studies all at once and just pull out the specific data you need. People call this the literature matrix approach. Take a tool like Elicit. You can tell it, hey, make me a table. Each row is a paper, and I want columns for sample size, methodology, and key findings. And boom, it creates it for you. It's an instant side-by-side comparison. Then you have tools like Paper Guide that go even bigger, automatically pulling data from hundreds of papers and even writing a report that points out where different studies disagree. Incredible stuff. All right, I know what you're thinking. This all sounds a little too good to be true. So, what's the catch? And you're right to ask. To really use these tools well, we have to be super realistic about what they can and can't do. So, this is the reality check. Let's look at the actual data, the pitfalls, and what it really takes to get good results. So just how good are they? This data is really, really interesting. Look at sensitivity. We're talking nearly 100%. What that means is the AI is incredible at finding pretty much every single relevant paper. It misses almost nothing. But then look at specificity. That tells a different story. The AI isn't so great at throwing out the irrelevant stuff. It brings you a lot of junk along with the treasure. So here's the takeaway. Think of it as a super enthusiastic assistant that brings you everything it thinks you might want. It's fantastic, but you, the human expert, still have to make the final cut. And this quote right here, it just nails the new mindset perfectly. AI outputs are treated as drafts to be audited rather than final verdicts. It's a first draft, not the final word. Some researchers found that if they asked a tool the same question multiple times, they'd sometimes get different answers. Now, that's not the tool failing. It's just a reminder that this is what we call a human-in-the-loop system. The AI does the heavy lifting, but the researcher's job, your job, is to check the work, to verify it, and to use your own expert judgment. So what does that human-in-the-loop thing actually look like in practice? Well, this 6-step workflow is a perfect example. You can see how it's a real partnership. Step 1. The AI helps you get familiar with the material by generating summaries. Then it might suggest some initial themes or codes. It'll even help group them. But notice, at every single step, review, refine, and finally, writing the actual story, the researcher's the one in the driver's seat. The human is always directing the process. So, when you step back and look at the whole picture, what you see is something pretty profound. It's a new kind of research partner. And let's be super clear, this isn't about replacing researchers. It's about augmenting them. It's about freeing up our brain power to focus on the work that really truly matters. And this really is the big picture. For so long, a huge chunk of a researcher's job was just grunt work. Manually finding papers, organizing them, pulling out data. The AI is now automating all of that. So the value of a researcher is shifting. It's moving up the stack to the more strategic stuff, asking better questions, designing more creative studies, and making sense of the results with real human insight. It's like the machine takes care of the what, which frees up the human to focus on the so what, and that's a huge deal. So let's wrap this up with some clear, practical advice. If you're a researcher looking to get started, here are the best practices. First, know your tools. Pick one for discovery, another for extraction. They're not all the same. Second, and this is the big one, always audit the output. You are the expert in the room, not the AI. Third, get good at prompting. The better you guide the AI, the better your results will be. And last but not least, be open about it. Be transparent in your publications about how you used AI. And all of this leads to a pretty deep final question. As AI becomes this essential partner in the lab, what does it even mean to be a brilliant researcher anymore? The skills are totally changing. It's becoming less about how much you can remember or how much manual work you can do, and way more about your curiosity, your critical thinking, and your ability to point these powerful tools in new and exciting directions. So the question we're left with is this. It's not just about what you know anymore. It's about what you can discover.